group representation, and this is the list of my members. List of topics to discuss. Number 1 is concentric circles in nature. Number 2, formula. Number 3, define tessellation. Number 4, types of tessellation. 5, transformation, tessellation. And last is to present the video of my member. Concentric circles in nature. Concentric circle means the circles all share the same center but have different radii. This means the circles are all different sizes, one inside the other. But we also see concentric circles in the layers of an onion and the rings of trees that form as it grows and ages. What do concentric circles mean? Concentric circles are circles with a common center. The region between two concentric circles of different radii is called an annulus. Any two circles can be made concentric by inversion, by picking the inversion center as one of the limiting points. What is an example of concentric circles? Answer. An example of concentric circles is the shapes in the trunk of a tree. Ripples in water when a stone is dropped. When you cut an onion, you can see concentric rings. So this is my example of concentric circles. What is the formula of concentric circle? Answer. The equation of or formula is close and open parenthesis x minus h squared plus close and open parenthesis y minus k squared is equal r squared. We have provided a detailed explanation and proof in the article. What is an example of concentric circles? Example number 1. Prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the points of contact. Solution. We are given two concentric circles, C1 and C2 with centri O, and the chord AB of the larger circle C1, which touches the smaller circle C2 at the point P. Here, we need to prove that AP equals BP. Let us join OP, then AB is a tangent to C2 and P, and OP is its radius. We know that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So OP and AB. Now AB is a chord of the circle C1 and OP, then AB. Therefore, OP is the bisector of the chord AB. As the perpendicular from the centre bisects the chord, AP equals BP. Patterns and numbers in nature. Patterns in nature are visible regularities of form found in the natural world. These patterns recur in different contexts and can sometimes be modeled mathematically. Natural patterns include symmetries, trees, spirals, meanders, waves, foams, tessellations, cracks, and stripes. Define tessellation. A tessellation or tiling a flat surface is the covering of a plane using one or more geometric shapes called tiles with no overlaps and gaps and no gaps. In mathematics, tessellation can be generalized to higher dimensions and a variety of geometries. A periodic tiling has a repeating pattern. Some special kinds include regular tilings with regular polygonal tiles, all of the same shape, and semi-regular tilings with regular tiles of more than one shape and with every corner identically arranged. The patterns formed by periodic tilings can be categorized into 17 wallpaper groups. A tiling that lacks a repeating patterns is called non-periodic. An, ap- an periodic tiling uses a small set of tile shapes that can form a repeating pattern. In the geometry of higher dimensions, a space filing or honeycomb is also called a tessellation of space. So this is the regular tessellation. And then this is shapes that will tessellate. Congruent shapes are shape of exactly the same shape and size. Congruent shapes that tessellate include 1. Squares. 2. Rectangles. 3. Equilateral triangles. Number 4. Hexagons. Then shapes that will not tessellate. Circles and ellipses. Interesting tessellation or tilings. Number 1 is rhomboli tiling or rhombal tiling. Number 2 is florid pentagonal tiling. Define tessellation. There are three types of tessellation. Number 1 is translation, number 2 rotation, and number 3 is reflection. Transformation tessellation. Unsuccessful tessellation occurs when a polygonal is repeated in a plane and gaps or overlaps and are formed. Transformation. A transformation occurs when a polygonal is transformed, resulting in a change of its position, shape, or size.
Good day, sir. I am Shalamari Al-Saging, first year section my group 3. This day I want to discuss utilization. Number 1. What math concept is fully discussed on your assigned video? So, it's all about utilization. Utilization is created with the shape repeated over and over again, covering a place without a caps or an overlaps. There are three basic shape in utilization: triangle, hexagonal, squares, and have a three roles of utilization: translation, rotation, inclined reflection. Number 2. What is about the concept? Cite few more real-world case or examples that will show concept. This is not the official name of the model, but rather the way I like to call it. Actually, a simple model, just make a bunch in squares, triangle, and then the triangles in couples. Example, Rubik's. Rubik's is there have 6 squares and 6 colors. Number 3. What are your insight about these mathematical truths or certainties? Mathematical is not all about the number. It also have about pattern and shape. That's all, sir. Thank you.
Good day, everyone. My name is John Mark Sabloron from Section Mike from Group 3. This is my answer from the guide question. Unang pangutana, what make concept is fully discussed in your assigned video? Kung akong answer is about tessellation. Tessellation is a shape that repeats to make pattern. Ginapon siya tulo ka basic shape. Una, number 1 is triangle. Ikaduha, hexagon. Ug ikatulo, square. There are 3 rules: translation, rotation, ug glide reflection. Ug ikaduha nga pangutana, what is about this concept? Cite few more real-world cases or example that would show the concept. Example na is square. Kanang square is kung ato nang balik-balikon og draw, makabuo ta og tinatawag nato nga pattern. Example na is triangle. O ikaduha, hexagon. Busa daghan tang uban og dili na nako isa-isahon kay kung ako isa-isahon magabihan gyud ta ani. Proceed ta sa ikatulong nga pangutana. What are your insight about this mathematical truth or certainties? So, kung mag-isgot tag mathematics, diba, kabalo naman ta, kung mag-isgot tag mathematics, mag-isgot yun is about sa number, nag-isgot siya number. So, sa nakita na ako nga sa video nga gi-assign sa MUA, nakaingon ko nga, dili lang di ay number ang gisgutan kung mag-isgot tag mathematics. Nag-isgot po siya mahitungod sa mga shape or pattern or ginatawag nato nga tessellation. So dinhi lang ko kutob kay ang atong oras time na. Again, good day everyone, and that's all. Thank you.
Good afternoon, sir. My name is Jelo Kibol, first year Criminology, Section Mike, Group 3. For now, I will discuss the tessellation. First question, what math concept is fully discussed on your assigned video? A tessellation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. Second question, what is about this concept? Cite few more real-world cases or examples that would show the concept. Tessellation puzzle combine art and math to stimulate creativity. Most of them are simple enough for 5 years old, but can also challenge older kids and the brainiest adults. Sample: triangular tailing, one of the 3 regular tailings of the plane. Second sample, snub hexagonal tailing, a semi-regular tailing of the plane. Question number 3. What are your insight about these mathematics, truth or certainties? First of all, I thought mathematics is just numbers, addings, and etc. But I was wrong because mathematics is also have a shape of patterns. Thank you very much.
Good afternoon, sir. I'm Roger Jan Artura, first year college criminology from section Mike Group 3. What math concept is fully discussed on your assigned video? Tessellation can be found in many areas of life art, architecture, hobbies, and many other areas. Hold examples of tessellation found in everyday surroundings. Question number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. A tessellation or tailing of a flat surface in the covering of a plane using one or more geometric shape called tiles with no overlaps and no gaps. In mathematics, tessellation can be generalized to higher dimension and variety of geometrics A periodic tailing has a repeating patterns. Examples of puzzles: florid pentagonal tailing dual to a semiregular tailing and one of 15 monohedral pentagon tailings. Question number 3. What are your insight about these mathematical truths or certainties? I thought is mathematics is numbering and addings. I'm wrong, but there are shape of patterns. Thank you, sir.
Hey sir, my name is Iber Precioso from Group 2. So I'm here to talk about tessellation. First question is, what math concept is fully discussed on your assigned video? So it's all about the tessellation. Tessellation is created when shape is repeated over and over again, covering a place without any gaps and overlaps. So we have three basic shape on tessellation. First is triangles, hexagons, and squares. And you have three roles in tessellations: translation, rotation, and glide reflection. So, and question number 2, what is about this concept? Cite few more real world cases in example that would show the concept. So, like Tora said, example is the Rubik's cube. We have many shape in Rubik's cube. In the common cube is the square. So as a national player of this Rubik's cube is, I have encountered many patterns in solving. So like this. We have many patterns to learn about this cube. First is this pattern. Second one is this. And this is the basic pattern in the in this cube. So this is the example of would show the concept that of distillation. And third one is, what are the insight about, so my insight about the mathematical truths or and certainties. And I used to think that math was numbers or solving, even though shape is part of math and patterns. So my so in without shape there is no tessellation, and without shape or patterns there's no tessellations. That's all, sir. Thank you.
Good day, sir. I'm Von Arsaligi from Section Mike, and this is Group 3. So this is my answer from your guide questions. First, what math concept is fully discussed on your assigned video? It is all about the tessellation. A tessellation is a shape that repeats to make a pattern. And there are three basic shapes of tessellation, which is triangles, hexagons, and squares. And there is also three roles of tessellation, which is translation, rotation, and glide reflection. Second, what is about this concept? Cite few more real-world cases or examples that would show the concept. Like for example, sir, tiles. Tiles gives us gives pattern that includes tessellation and its basic shapes of tessellation, which has triangles, hexagons, and squares. Third, what are your insights about these mathematical truths and certainties? From my expectation before, I expected that mathematics is just a number, but now I'm in college now. I realized that mathematics has full of patterns that could make the things beautiful.
Good day, everyone. I am Mark J. Sanipa from Group 3, and this is my answer from the guide question. The first question is, what math concept is fully discussed on your assigned video? It's all about tessellation. It is a shape that repeated to make a pattern. The second question is about concept. Cite few more real-world case or example that would show the concept. The example is a Rubik's Cube. The Rubik's Cube represents other shape like triangle, hexagon, square. But square Rubik's is the most common. The third question is, what are insights about the mathematical truths, certainties? I thought mathematics is all about adding, subtracting, multiplying, dividing numbers. But because of this tessellation pattern, mathematics is also tackled about tessellation. And that's all. God bless
My
everyone.
name is Nirindon Pimentel and I will going to answer the guide question. First question is, what math concept is fully discussed on your aside video? The math concept discussed is all about tessellation. Tessellation is a shape that repeats to make a pattern. And also tessellation have three basic rules. 1. Translation, rotation, and glide reflection. Question number 2. What about this concept? Cite for more real-world cases or example. What should show the concept? Tessellation is a pattern of shape that fit together perfectly without any gaps. And my example on this is this pineapple. This pineapple have hexagonal pattern, so we can consider this as a tessellation. Question number 3. What are your insight about the mathematical truths or certains? My insight is mathematics is not only about numbers and addition, subtraction, and multiplication, but it also have different shapes or pattern that we can see around us.
The concept is the fully discussed in the assigned video is a pattern geometric shapes that fill is no gaps and no overlaps that repeats forever in all direction. They can be composed one or more shape. 2. Tessellation can be found in many areas of life, art, architecture, hobbies, and many other areas. Of all tessellation found are in everydays. Example, architecture, carpets, origami, and etc. My insight in mathematical truth is that tessellation is created shape repeated over and over again, covering a plane without any gaps, and if you look out completed tessellation you will see the original motif repeats in pattern.